All right, buckle up everyone, because today we're diving deep into Snowflake. And I mean really deep.
Deeper than we've ever gone before.
You bet. We're talking about micro-partitions, clustering keys, and how to make your queries lightning fast. We've got some incredible insights to share with you today, all based on the work of John Ryan.
Ah, John Ryan, the Snowflake Whisperer.
Exactly. He's helped over 100 companies optimize their Snowflake deployments. He really knows his stuff.
And he actually just launched a new training course, didn't he?
He did. Mastering Snowflake, Fundamentals, Insights, and Best Practices. If you're serious about taking your Snowflake skills to the next level, you can check it out at www.analytics.today.
Nice. Definitely going to have to check that out myself.
You should. So, in this deep dive, we're focusing on one of John's key techniques, clustering keys. And get this, he's got real-world examples where he took queries that were taking like 20 minutes to run and got them down to just a couple of seconds.
Wow, 20 minutes to 2 seconds. That's insane. I'm already intrigued.
I know, right? So are you ready to unlock that kind of speed in your own work?
Absolutely. Let's do this.
Okay, so first things first. We need to understand how Snowflake stores data. It's a bit different from traditional databases.
Right. It doesn't use rows like we're used to.
Nope, it uses a columnar format. Think of it like a really, really organized spreadsheet where the data is grouped vertically in columns instead of horizontally in rows.
Ah, okay. I'm starting to see the picture.
And this is a big deal for analytical queries because you're often just interested in specific data points, not entire rows, right?
Yeah, totally. It makes sense to just grab the data you need instead of pulling everything.
Exactly. It's like instead of pulling an entire file cabinet every time you need something, you could just grab the specific folder you need.
Much more efficient.
Way more efficient. And Snowflake takes it a step further. They break those columns down into these compressed chunks called micro-partitions.
Micro-partition. Okay.
Yeah, each one is about 16 millibit. And this not only makes storage more efficient, but it also speeds up how quickly Snowflake can retrieve the data you're looking for.
Interesting. So it's like having your data pre-sorted and labeled in those folders you mentioned.
You got it.
Okay, I can definitely see how this is way faster than the traditional way of doing things.
Right. But how does Snowflake actually use these micro-partitions to speed up queries? That's the real magic here.
Well, when you load data into Snowflake, it automatically captures all this metadata.
Metadata, like what do you mean by that?
Think of it as a little cheat sheet with key information about each micro-partition, like what are the minimum and maximum values for each column it contains, things like that.
So it's like Snowflake is taking notes while it organizes my data.
Exactly. And these notes, this metadata, that's the secret sauce.
Okay, I'm listening.
So let's say you've got a query that's looking for sales data between certain dates. Snowflake uses the metadata to instantly figure out which micro-partitions might contain that data, and it completely ignores the rest. It's called static micro-partition elimination.
So it basically knows where to look and where not to look.
Exactly. Instead of searching every nook and cranny, it goes straight to the source.
I see. And this is where those huge time savings come in, right?
Exactly. Jet had a query running against this massive table, 4.7 terabytes of data with 72 billion rows.
72 billion rows. My brain can't even comprehend that.
It was initially taking 21 minutes to run, but by using this micro-partition elimination, he got it down to under 2 seconds.
No way. 2 seconds. That's unbelievable.
It is pretty wild.
Okay, so now I'm curious. How can I tell how well clustered my data is? Is there a way to measure that?
There is. Snowflake has this function called system clustering information, and it gives you these metrics like average depth and maximum depth, and they basically tell you how many micro-partitions Snowflake needs to scan for a typical query.
Okay, so if I'm understanding this correctly, lower numbers are better, right?
Exactly. Lower numbers mean your data is well clustered, and that means faster queries.
Got it. So low depth, good. High depth, not so good.
Exactly.
Okay. But here's the thing that's bugging me. Data is constantly changing, right? New records are being added, old ones are being updated. Doesn't that mess up the clustering?
It can, but Snowflake's got you covered.
Oh, how so?
Automatic clustering, it's like this background process that's constantly working to keep your data organized and maintain optimal clustering.
So even when things are changing, Snowflake is working behind the scenes to make sure my queries stay fast.
That's the idea. Like, let's say you update a row in your table. Snowflake actually creates a whole new version of the micro-partition that contains that row.
It's like a super organized librarian who constantly reshelves the books to keep everything in order.
Exactly. But, and this is important, all this reclustering does come at a cost.
Right. That makes sense. So it sounds like there's some strategic decisions we need to make about when and how to use clustering effectively.
Absolutely. There are definitely trade-offs to consider.
So it sounds like we need to be careful about not overusing clustering, right?
Yeah, exactly. Just because you can cluster a table doesn't mean you should.
So how do we figure out if a table is being updated too frequently? Like, where do we draw that line?
Well, one way to think about it is kind of like checking a patient's vital signs.
Okay, I like where you're going with this.
Right. If there's too much activity, it might not be the right time for surgery.
So in this case, surgery is adding a clustering key.
Exactly. And one of the key vital signs we want to look at is how many updates and deletes are happening on a table.
So like a really active table that's constantly being changed, that's probably not a good candidate for clustering.
Probably not. The cost of constantly reclustering might outweigh the benefits you get from faster queries.
That makes sense. Is there an easy way to figure out how much activity is happening on a table?
Oh, yeah. John actually provides a SQL query in his work that can help you with that.
Oh, cool. So we can actually use SQL to check those vital signs and see if a table is a good fit for clustering.
Exactly. It basically taps into Snowflake's query history and can flag tables that are seeing a lot of changes.
That's super helpful. Okay, so let's say we've identified a table that is a good candidate for clustering. How do we pick the right column to cluster on?
Good question. There are a bunch of factors to consider, but one of the biggest is which columns you're using most often in the where clause of your queries.
Okay, so the columns I'm filtering on most often, those are the ones I should consider for my clustering key.
Exactly. You want to organize your data based on how you actually use it.
Right, makes total sense. It's like organizing a toolbox so the tools you use most often are right there in front.
Perfect analogy.
Okay, so that's one thing to consider. What else should we be thinking about when choosing a clustering key?
Another big one is data type. You absolutely want to make sure your data is stored in Snowflake using the correct data type.
Like dates should be stored as dates, numbers should be stored as numbers, that kind of thing.
Yeah, exactly.
And if it's not, what happens? Does Snowflake just not cluster it?
It might try, but it's not going to be nearly as efficient. It's like trying to sort a pile of objects without knowing if they're books or tools or toys.
Right, that's not going to work out very well.
Yeah.
Okay, so data type, super important. Anything else we should be watching out for?
Well, this is kind of a weird one, but Snowflake actually only uses the first 5 characters of the clustering key.
Wait, seriously, the first 5 characters?
Yeah, which can actually be a problem if you're not careful.
How so?
Well, let's say you're trying to cluster on a timestamp column, right? And those timestamps include milliseconds.
Okay, yeah. Timestamps can get pretty long.
Right, and they have a lot of unique values. So if Snowflake's only looking at the first 5 characters, you could end up with way too many micro-partitions.
And that's bad because,
Well, it kind of defeats the purpose of clustering. Remember, the whole point is to group similar data together. But if you have too many micro-partitions, you're not really grouping anything effectively.
I see. So too much detail can actually be a bad thing in this case.
Exactly. It's like trying to organize a library by using the full ISBN as the sorting key, complete chaos.
Okay, good point. So how do we avoid falling into that trap?
John suggests using what he calls a truncated timestamp. So instead of clustering on the full timestamp with milliseconds, you just use the day, or maybe even just the hour.
Oh, so we're basically grouping things into more manageable chunks, right?
Exactly. And it's much more useful for most types of analysis anyway.
Makes sense. Okay, I'm really starting to see the art behind this whole clustering thing. It's not just about setting it and forgetting it. There are a lot of nuances to consider.
Yep, you got it. And we're not done yet. There are a few more tips and best practices we should cover.
All right, let's hear them. What else should we know about clustering in Snowflake?
Well, one thing I wanted to touch on is how to handle that initial clustering effort. When you first decide to cluster a table.
Right, because Snowflake does automatic reclustering, but that's for tables that are already clustered, right?
Exactly. But if you've got a brand new table, or maybe you've decided to add a clustering key to an existing table, that initial clustering process can take a while.
Oh, I bet. Especially if we're talking about those massive tables with billions of rows.
Right. It can be really slow and resource intensive. So there's a trick you can use to speed things up.
Ooh, I'm intrigued. Tell me more.
You can actually manually pre-sort the data before you let Snowflake do its thing.
Wait, so we can help Snowflake out by doing some of the heavy lifting ourselves?
Exactly. It's like giving Snowflake a head start in a race.
I love it. So how do we do that?
It's pretty straightforward, actually. You can use a simple insert overwrite statement with an order by clause to get things organized.
Okay, so we're basically pre-sorting the data based on the column we want to use as our clustering key.
You got it.
That's a really cool tip. I can see that saving a lot of time, especially when you're dealing with huge data sets.
It definitely can. And one last thing I wanted to
Oh,
mention.
poor.
Remember how we talked about those vital signs earlier and how too much activity on a table can make clustering less effective?
Yeah, I remember.
Well, there's a way to manage that even if you do decide to use clustering.
Oh, how so?
You can actually tell Snowflake to pause automatic reclustering during those busy periods. Like, if you know you're going to have a ton of updates happening, you can just tell Snowflake to chill out for a bit.
So we can give Snowflake a little break when it's already working hard.
Yep. And then you can resume the automatic clustering later when things have calmed down.
Ah, that's really smart. So we can still get the benefits of clustering without constantly hammering our system with reclustering tasks.
Exactly. It's all about finding that balance between performance and cost, right?
Right. Well, I feel like we've covered a ton of ground already, but I have a feeling there's still more to learn about clustering. What else should we be considering?
Yeah, there's one more really important piece to this puzzle. We've talked a lot about how clustering works and how to do it effectively, but we haven't really talked about when it's the right approach in the first place.
All right, so clustering, it can really speed things up in Snowflake. But it's not always the right answer, is it?
Exactly. It's like you wouldn't use a hammer for every job, right?
Makes sense. So when does clustering really make a difference?
Well, John highlights a few key scenarios. For starters, if you're dealing with massive tables like terabytes of data or even bigger, clustering can be a game changer.
So the big data situations.
Yep. Think of it like, organizing a giant warehouse. You don't want to be searching through every aisle to find what you need.
Right. You want to know exactly where everything is. So clustering helps Snowflake find the right data quickly.
Exactly. Another scenario where it shines is when you have a table that's constantly being queried, especially complex analytical queries.
So it's like creating an express lane for your most frequent queries.
You got it. And, if you're seeing queries that are scanning a large percentage of a table, clustering can really help reduce that scanning and speed things up.
It's like instead of having to read an entire book, you can just jump to the chapter you need.
Perfect analogy. And of course, if you've already tried other optimization techniques and your queries are still running slow, clustering might be the missing piece of the puzzle.
So it sounds like clustering is definitely a powerful tool to have in our Snowflake toolbox.
Absolutely. But remember, it's not a magic bullet.
Right. When might it not be the best approach?
Well, like we said, clustering comes with overhead. If your tables are relatively small, your queries aren't too complex, or you're not really having performance issues, then adding clustering might actually make things worse.
Ah, so we don't want to over-engineer things if it's not necessary.
Exactly. Sometimes a simpler solution might be more effective, like just optimizing your queries.
So the key takeaway here is to really understand our data and our performance needs before we jump into clustering.
Couldn't have said it better myself. It's all about using the right tool for the job.
Well, this has been an amazing deep dive. I feel like I've learned so much about clustering in Snowflake. We've covered everything from how it works at a technical level to the strategic decisions around when and how to use it effectively.
I'm glad to hear that. And, if you want to learn even more, I definitely recommend checking out John's new training course, Mastering Snowflake: Fundamentals, Insights, and Best Practices. It's packed with even more tips, tricks, and best practices.
Awesome. And where can our listeners find that?
It's at www.osanalytics.today.
Perfect. A huge thank you to John and Ryan for sharing his incredible knowledge, and to you for walking us through it all. This has been incredibly insightful. And to all our listeners out there, keep experimenting, keep learning, and keep pushing the boundaries of what's possible with Snowflake. Until next time, happy querying.